you guys learned first shell, second shell, right? Madam Kim taught you that, first shell, second shell, right? The number in front of the letter represents the shell of the orbital. We call this quantum shell. So 1s refers to the s orbital in the first quantum shell. 2s refers to the s orbital in the second quantum shell. 2p refers to the p orbitals in the second quantum shell. So these numbers really just tell you which floor the orbitals are in. If you have an HDB block, level 1, level 2, level 3, level 4, and so on. That's what these numbers tell you. These orbitals are in increasing distance from the nucleus, so 1s is the closest, 2s is, and then it goes on and on and on. So, if you were to if you were to state the relative energies of these orbitals, 1s would be the lowest energy, 2s would be the second lowest, followed by 2p, and then you go on and on and on until basically infinity. 3s, 3p, and 2s. Okay, so notice that there's no 2d orbital. The d orbitals are you can think of it as like a video game. The d orbitals are only unlocked at the third quantum shell. The p orbitals are only unlocked at the second quantum shell. One thing to note is that the 3d orbitals are higher in energy than the 4s orbitals. So, no need to remember that thoroughly now, but when we get to writing electron configurations, this will come into play. And I will explain what that means. So, if you were an electron, you would obviously occupy the orbital of the lowest energy first, right? You would occupy the 1s first. So if I was an electron, I want to occupy the orbital with the least amount of energy possible. So I will fill up the 1s first, and 6. After 1s, I go to 2s. So I will fill 2s if the 1s is filled. And then so on, etc. So if we were to write the electron configuration, for example, of sodium, since we know these energy relations now.
Wait, when do you apply the F orbital?
The what?
F orbital.
4. Fourth quantum shell. So if I were to write the electron configuration of sodium, this is how I would do it. In a sodium atom, there are 11 electrons. So we gotta distribute these. We gotta give these guys homes. The electrons are gonna occupy the 1s first. 1s, 2. So the maximum amount of electrons any orbital can hold is 2. 1s2. How many more electrons do I need? I need 9 more electrons. So we keep going. 2s2. Okay, I have 4 electrons as I'm going. So I need 7 more. Now I'm gonna fill 2p. 2p. 6. So, hold on, you just said that each orbital will only hold a maximum of 2 electrons. But, and you've just written 6 here. Why is that the case? Well, there are 3 different types of p orbitals. 3 times 2 is 6. That's why. So, 1s2, 2s2, 2p6. How many electrons do I have here? I have 10. I need 11, so I just put 3s.
Wait, so you do the number of orbitals like for P and P increase?
What do you mean?
Like, for example, at 3 increase, it's not 3, and number 4 is 4P orbitals.
4p. No. You go 3s, then you go 3p, then.
No, I mean the orbitals per shell.
Okay, so orbitals per shell, they remain roughly the same. Roughly the same. The main things you're gonna be filling are S, P, and D. You don't really fill F. Why? Because F is so high in energy. You would need a lot of electrons before you can get to F. So let's do another example. If I were to write the electron configuration of potassium, how would I do that? Sean, how would I write the electron configuration for potassium?
1s2, 2s2,
Okay.
2p6.
Okay. How many more electrons do I need from here? 10 here.
Then it's another 9 more, so 3s2, 3 P6
Yes?
and 3 D1 or what?
You don't feel, okay, so you know how I said 4s is lower in energy than 3d?
Yes.
4s is lower in energy than 3d, so electrons are going to fill 4s first.
Ah, I see.
So then I have 18 electrons here. I need 19, so what do I fill?
14S1. 14S1, 4S1.
4s1.
Then what about 4P? Does it have a higher energy?
Yes, it does.
Right.
Alright, so let's do another one. Let's have some fun. Maybe give me an element, anything.
Iridium.
Not that. Give me a reason. Okay, let's do aluminium.
Organism.
Aluminium is 13. Okay.
Oh goodness, huh?
So Daniel, how would I write the electron configuration for aluminium? How would I write the electron configuration for aluminium? I would go 1s2, 2s2,
We move up to 2p6.
2p6. From here, how many electrons do I need?
I need 3 more.
3 more, so
3s2.
3. I need 1 more.
We go to 3p.
3p,
Just repeat.
3p1. Just check that's correct. 10. Okay, good. So that's how you write the electron configuration for aluminium. The best way at getting good at writing these is just doing a lot of practice. There's no easy way of putting it. So let's do that. How would I write phosphorus? The electron configuration of phosphorus. I mean, go.
1S2.
Ah,
2S2.
2s2,
2P6.
2p6. Good. How many more do I need from here? I have 10 here, so I need
3S6.
not. You can't fit. You ask it. 3s2.
Have you not been listening to this class?
7.
3D1.
3p4. You should. I
Are you
have.
okay? Is your math okay?
I have 12 electrons here.
GSG.
3p1.
GP.
What are you saying? Bro.
My man, I think